Alright, in order to simplify this radical expression, what I first need to do are simplify each of these radicals. And to do that, I could either use prime factorization, or for these numbers, for 112 and 63, I can look for the biggest perfect square that's a factor of them. 112 is 16 times 7, and 63 is 9 times 7. So I'm going to rewrite those in their factored form. Alright, here I have the factored form of both of these, the 16 times 7 and then the 9 times 7 here for 63. Then what I'm going to do is perform the square root on the 16 and the 9. When I do that, the answer to that is on the outside of the radical, and so that will look like this. It'll be 10 times 4, because that's the square root of 16, and what's still left on the radical is this 7x. In this right expression, I have 6 times 3, and then under the square root, I still have a 7x. Okay, at this point, then I'm just going to multiply the coefficients out front here. So I have a 10 times a 4, so I have 40 root 7x minus 18 root 7x. And now, since these radical parts are identical, the square root of 7x and the square root of 7x, I combine these through the process of like terms. So I have 40 root 7x's, and I'm subtracting 18 root 7x's, and what I end up with then are 22 root 7x. And again, that process, and you can use prime factorization for this and you get the same answer. But the idea is, I'm taking these numbers and the variables, but in this case the numbers are the only thing that's interesting. I'm going to find the biggest perfect square that's a factor of them. And in this case, that was, for 112 it was 16, and for 63 it was 9. I then perform the square root. The 16 becomes a 4 here on the outside, and the 9 becomes a 3 on the outside. Once I have those, I simplify. And then if I have like terms, which I did in this case, the root 7x and root 7x, I combine those. The 40 minus the 18 gives me the 22 here in my final answer.